Right then guys, we've got the pulley up in the chuck. We've bored it out to the right diameter for the new motor shaft. We've got a really nice finish in there as well, and that measures up about 10 microns bigger than the shaft, something like that, between 8 and 10 microns bigger than the shaft diameter. So it's got a little bit oversized on what I was expecting, but you know, even at that size I think that'll be okay. It will still be a good sliding fit on the shaft. So what I've done is made up a bit of a prototype really, and I've just knocked this up quick, and if this is successful I'm going to make something a bit more sort of universal for the lathe, for various different jobs like this, for screw cutting, internal threads and whatever like that. So I've knocked this bit of bar up just as a prototype, so it's just a bit of bar, 2 flats on it. We'll load that up in the tool post, and then what I've done there is I've made, just out of an old high-speed steel end mill, I've ground up a tool, like a shaping slotting type tool for want of a better word. Just hand ground it, measuring it with the verniers as I went. It's all quite tight, but I wanted to use the biggest diameter bar I could to give this as much support as possible. So we'll give this a go, we'll see how we get on. So what we're going to do is load that up now, and then we shall use the carriage to feed this through the internal bore to hopefully put the keyway slot in. And I don't know whether the camera will show this, but what I've tried to do here, just as a prototype, if you can see, the cutting edge is not perpendicular, and I've done that by design really, to try and see, I wanted to create like a shearing action as opposed to a blunt chisel edge action, just to see if that helps with the cutting. So we'll give it a go and see how we get on. So I'll get it set up and bring you back. Alright guys, we've got the tool set up as close as I can on centre, and I've got my depth stop set, I've got my E-stop on the machine pushed in, so there's no chance that I can, you know, even if I forget and turn the handles on, nothing nasty is going to happen. So we'll give this a try and just see how we get on. Let's give it a squeeze. I've got no cutting oil, so I'm just using a bit of 1040 motor oil for this. So we'll just put a tiny bit of cut on. Well, that feels good. It's cutting anyway. I think I need to do slightly smaller cuts than that. Yeah, that feels nicer. It's cutting nice. Nice swarf coming off it. It's not sort of galling it off, it is actually cutting it, so I can't see any deflection of the tool. I can't feel any, I can feel some deflection in the tripod. I can't feel any nasty sort of for a shaper. I think I'm all out of buying new machine tools at the minute. Right, I'm going to move the tripod out of the way and have a bit of a, where I can see what I'm doing a bit better, and I'll bring you back when we're somewhere near finished. Right, we're into depth, guys. So what I'm doing now, I'm slightly thin on my width. So I've just lifted I've put a clock on the top and I've lifted the tool post. Well, I've gone up and down actually, so that I'm equal about what I think is the centre. And I'm just, I think, taking the final skim off the top face, the underside of the top face. I thought I'd show this from a bit of a distance just so that you can see the process of me in and out and gently pitching on the cross slide. And I've got quite a, it's almost like watching a shaper work. So hopefully that should be us on finished size there now, all being well. It's quite hard to nope, I need a bit more out. I'm not subjected to more of that hypnotic jiggling. I'll do that on my own and bring you back when I'm finished. Alright guys, that's us. As best I can measure it in the machine. I am 1/2 mil clear on the top of the slot, and on the width of the slot I'm 0.05, which is 0.05 a millimetre, which is a thou a side, or 0.025 of a millimetre a side on the width, which I think is good enough. We will see. So we'll get that cleaned up and deburred, but I'm chuffed with that. I don't know whether the camera's showing, but that's done a really good job actually. Left a decent finish in there. So we'll get that deburred and we'll go and give it a trial fit on the shaft. What I might just do is whip this round. You can see I've cleaned up the OD on this side. I've taken a light facing cut on this back face just to get rid of some of the grot and dings. There's a few dings still in it, but it's good enough like that. I think I might just turn it round while I've got it out and just clean some of this, or even I might just do it by hand actually with a bit of Scotch-Brite just to clean this belt rubber, I suppose, and just muck, general muck. There's a couple of little dings on it, so we'll just clean them up. I'll probably just do it by hand rather than putting chuck jaw marks in this back diameter. I think I'll just do it by hand. So we'll clean it up, we'll give it a try. Alright then guys, the moment of truth. So this is the new spindle, well, the new motor spindle, sorry. Let's give that a clean, make sure there's no muck or anything on it, or any burrs or anything like that on that key. That all feels good. What I've done is I've just given the front end of this just a bit of a clean up with a bit of Scotch-Brite, really deburred bits that I needed to deburr, so we'll give it a shot and see what we get. I'm happy with that. Just a nice sliding fit. It like I said, it's tiny little bit too big on the bore that I did. I'd have liked it a tiny bit tighter than that, but there's no play on that. so I'm happy with that. That's just a nice sliding fit, probably a bit too nice sliding actually, but anyway. Well, there we go, that's John's Workshop's first keyway. I'm really pleased with that tool. That's done I don't know whether the camera will really show this, but it's done a really good job. There's probably a bit too much light in there, but I know it's only aluminium, which has made the, you know, if it had been steel that would have been a much more of a challenge, but yeah, I'm chuffed with that. That's done a really good job of putting that in, so that's another job for the future. I'm going to make something that goes on the either on the cross slide of my lathe, or I might need to make it so that I take my compound slide off the top and make something that fits onto there, or potentially something that fits onto where the Dixon tool post is at the minute. I'll give that some thought, but I'm going to design something that's probably double-sided so I can stick a tool in the back and a tool in the front, and it could just be for boring bars or stuff like this, but I'll have a think on that, because yeah, it would be nice to have a shaper in the shop that does this kind of thing, but I don't have one at the minute. But this is a get you out of jail free card in terms of being able to put keyways in. It, you know, it clearly does the job. It's done a good job of that. I'm chuffed with that, so I might think about making something a little bit less prototypey than the one that I made, because I did knock that up really quick. I just knocked that up in sort of half an hour, bit of grinding, couple of holes, tapped hole. It was a little bit, you know, I didn't really put a lot of shall we call it accuracy into it. I was just almost eyesight in centre lines and things like that, just because I wasn't sure whether it would work or not, but I'm really chuffed for that. So good, that can now get fitted onto there, and we'll get that mounted back in the bottom of the grinder. And then oh, before I do that, next job, I need to get the wiring fitted into this end first before I put it back in the machine. While it's up on the bench, that's nice and easy, so we'll get the wire put in, we'll get the jumper settings right for in the box for 240 volt, and close all that up, and then we'll drop this back in the bottom of the machine. So I'll bring you back when I've done that. Alright guys, there we go. There's the new motor with its fancy skis all in place in the bottom of the machine, and I've just got one little bit of wiring left to do. I've pulled a spare earth wire out from the motor, from the earth that comes in from the main supply through the variable frequency drive, and what I'm going to do with that is extend that, just using a connector block or something when I get a bit more wire, and I'm going to route that out to somewhere on the machine body itself to earth the machine body. It would probably get an earth through what I've already done through the motor, but just to be double sure, I'm going to just run an extra earth wire onto the body of the machine. So that's pretty much it for the motor end, so we can start now rebuilding the top end. So just before I start, and just to kind of address some comments and feedback that I've had, a couple of people have said and pointed me towards a couple of posts on, I think it was a model engineering forum or something. Apologies, I forget who it was, so please accept my apologies for that, but I have been and viewed the posts, and they've suggested that the way I'm going to reassemble this, which is the way it came apart, well, this is the back end we're looking at here, so having the two opposed taper roller bearings with the spacer in between at this back end, which is largely what I took out, except there are angular contact bearings, and a single deep groove ball race at the front, which is how it was originally. And they've said it would be better to have the twin bearings at the front and a single bearing at the back, which is exactly how lathes.co.uk says it is. And I don't disagree. I think that would definitely be much more sturdy at the front end, where the wheel is, where you need it. The issue I've got with that, and if I could do that, I would probably do it, to be honest. I think there's just about enough room on the shaft without modifying it to do it. But the issue I've got with it, this back end is plain bored out at 2 inches all the way through to the spacer, so there's enough room to get both bearings in and the spacer at this back end. And I'll just whip you around to the front end now and show you what I'm dealing with at that end. So we're now looking down the spout of the front end, and what you can see is there's a 2-inch diameter bored out for about 1 inch. Now the bearing is 3/4 of an inch wide for the sort of deep groove ball bearing that I've got. Behind that it's not machined, and originally I wondered if this was some kind of a sleeve, but it's not. It's part of the original casting. So for me to put both bearings in this front end, I would need to split this whole top casting away from the rest of it, mount it up on, probably on my milling machine if I'd got the room, which I don't think I've got enough under the head to do this. I certainly couldn't swing this in the 4-jaw because it's far too big and too heavy for my lathe. It would just have it dancing round and it would just rip it out of the chuck. So I would have to bore this out to the 2-inch diameter. This is really unmachined, this back diameter. It's machined, but it's very rough. And I suppose I could look for 2 much smaller bearings and make a stepped sleeve to fit in here, and then fit the bearings into a sleeve. But you know, if I'm reducing the diameter by sort of at least 1/4 of an inch, if not more, to get enough wall thickness, it would have to be more than that actually, because I'd need to come 1/4 of an inch in from this smaller diameter at the back. I think the losses I'm going to gain from going down to some weedy wimpy bearings like that is probably not worth the benefit. So the only real way to do this properly is to have this front end bored out fully. So I can't really, and that's what leads me to believe that this is factory the way it is. That's the only reason that I think this is a factory unit, because I think this is how it's come from the factory when it was done. And I would imagine originally this rough bore would probably had the bronze sleeve pressed into it, front and back, and it would have been parallel. And I think what they've done is, when they got to the later models in 1950 and replaced the bronze plain bearings with the roller bearings that I took out, they've probably modified the original casting. I can't imagine they would change the casting for that small mod, so they've modified the original casting by boring just enough depth to put the single row deep groove ball race in the front. So that's what I'm sort of stuck with. So I don't really have the option without taking this off and sending it away to somebody who's got machinery big enough to cope with boring that out. So for now I'm going to replace it as I took it apart. We will see how we get on with that. If I think there's weaknesses in that system and it's not ideal, then I can always go back and stare at this again and see what other options I might have. So based on that, we're going to start cleaning this up. I mean, I've cleaned, you would not believe the amount of grease that I took out of here. I've taken a good cupful out of front and back. It was absolutely packed. There was 4 different types of grease in here, and the oldest grease, which was closest to the bearings, it was green. It looked really old. It was really quite smelly. And then there was 3 other different colours of grease to the newest grease, which was black, which is what's coming in through the greaser. So yeah, it leads me to believe that those bearings have been in there a long time, based on that sort of history that I found in there. So we'll carry on cleaning this up, and I'll bring you back when we're thinking about fitting the shaft back in with the bearings on it. Right then guys, we're going to try this. So I've had both my bearings sat on that radiator for about an hour, and they're in the box, they're handleable just, so they're probably at about, I don't know, 40 degrees, something like that, maybe a bit more, maybe 50 degrees, something like that, 50 degrees C. So just based on how easy the last bearings came off the shaft, I think that'll be enough heat that these just drop on. So we'll give that a go, and I don't think, obviously that's not going to do them any damage at all, and they're still all wrapped up inside in the bags, so no risk of them getting dirty or whatever. So I'll bring you back in a minute and we'll see how we get on. So apologies I didn't film that, guys. I just wanted to sort of concentrate without the tripod in the way, and I wasn't quite sure how these were going to go, and to be honest I greased a pair of the bearings up. I've obviously cleaned, there's a spacer under here, the original spacer, the small one, there's the big spacer there, and the two bearings. Now I've packed that middle spacer I've packed that middle spacer with grease around the shaft, so there's plenty of grease in that middle spacer, and I've greased up the two bearings, not too liberally but with enough grease. You can see some residue around the top there, so I've not gone to town, but there's more than enough grease in those bearings squashed in well between the rollers. So I just need to now clean up the threaded nut for this end, and we'll have a bit of a play with preload and see what that looks like, and then at that point that shaft is ready to put back into the casting. Okay, so we're ready for the final fit up. So I've cleaned this really thoroughly inside here, and what I'm going to do is just 2 or 3 drips of oil in there, that's all. And I've got a clean I've got a clean finger. It is clean, there's no muck on it. And I'm just going to give that a tiny, the lightest smear of oil, just to help assembly. No more than that. 2 or 3 drips should be all it takes. Right, let me go and get some stuff together. So we've got our key, our pulley, our belt. Let's not forget that, after I just reminded myself to do that. So we've got our belt ready, and our shaft. So there goes nothing, guys. I'm just going to put just the tiniest drip of oil inside that pulley bore, again just to help ease the assembly a little bit. This is where you need about 10 pairs of hands. I know you can't see what I'm doing, apologies. So we'll put our belt on the pulley. We'll drop the belt through the casting. Something like that. Carefully slide the shaft through. To get the key. That's going to need a bit of persuasion. I'm going to have a little think about that before I start knocking things around in terms of how best to knock that in without causing damage to the bearings. I don't know whether I need to make a little spacer up to fit on the outside of this shell and knock it there. That would put the force into that spacer, into that shell, whereas if I knock it from the centre, I'm going to be putting all the force through both bearings. So I probably need a spacer. I'm just going to give it the lightest of taps on this end before I go to the trouble of making or finding something to fit that as a spacer. If it's a gentle tapping, I think it'll be fine. If I need to start braying hell out of it, then that's obviously not going to do the bearings any good at all. So let me just I'll just go and get a gentle persuader and we'll try our luck. So gentle persuasion is not going to do it on this end of this nut. So what I've done is, fortunately, the angular contact bearings that came out of here actually press apart. So I've pressed one of them apart, made sure it's clean, and I'm just gently, and I mean gently, and this is going to take me quite some time, just basically a bit at a time, just going round like this, and it is actually moving in very slowly. And I know there's probably quicker ways of doing it than this, but I'm comfortable that doing it like that, I'm not causing any damage to those new bearings. So I'm going to do the rest of that off camera, and I'll bring you back once I've got it all into position, hopefully. Right, so that's as far in as that goes, and the reason for that is, if I go any further, and I've been just gently creeping up on this, just using the bearing shell on the outside, just gently working it in, and all of a sudden I heard a change in the sort of resonance of the thing. So I stopped and I checked the spindle, and it had kind of tightened up a little bit, which kind of meant I was hard up against the spacer, the small spacer at the front of the bearings. So then I've just given it a tiny tap on the front end just to bring it back off that spacer, and that's just how it was when I took it apart. So I'm back to that same position. It's quite stiff, but these are new bearings obviously, and I don't know how much preload I've put on yet, so I was going to leave that until I just all I did there was nipped it to take the slack out. At that point I've not really put any load on that yet, so still to play around with that. Right guys, we've got that bit done, all nice and free, no rubbing, nice and quiet. What I have done is I've just put a clock on the front of the spindle. In fact, I'll just move the camera. So just out of interest, I've just put DTI on the wheel surface that the wheel locates on through the hub bore, just to see how that was running, just holding those back bearings. And I've got about 5/10 of a thou run out, best I can measure, but there's absolutely no lost motion in it. So I've got 5/10 of a thou run out. So what I don't know is what that's going to be like when we get the front bearing in. So next job is to get that front bearing in, and then we'll just recheck that and see if that's improved any or got worse. I don't suspect it's going to get worse, but you never know. So we'll get the front bearing ready and we'll get that fitted now. Right guys, that's got the front bearing in. Went in fairly easily, not really needing a lot of work, just some gentle, persistent persuasion, and I mean gentle. I didn't need a lot, so that's gone in. Everything still spins nicely, and I've just set the clock up on the spindle, so I'll just reposition the camera and show you the clock, and that's about it. We'll start putting the last bits back on the front, and then I think we're ready for the big wire up. See if we can zoom you in a tiny bit on that clock. So that's 1/2 graduations on there. Let's try spinning that again. So you can see there's absolutely nothing on that at all. So I'm really pleased with that. That's excellent. So what I'm going to do now, I've just got the front casting that goes on this front end to clean up, and the spacer that fits inside it. So I'll get those two cleaned up and fitted. Nothing special, it's just 3 screws that hold that on, and then we'll fit the wheel back on, and then we're ready to probably tackle the VFD at that point. In terms of, I've got the motor wired up, but I need to position the VFD somewhere and then get that wired up. So that'll be the next task. I'll bring you back when I put this front end back together. Alright then guys, that's got us all back together. Wheel on, guard back on, front cover back over the bearing, and everything ready to go. Feels the belt's back on and sort of tension, so all we need to do now is wire it up and see what happens. So next job is to get the VFD up on the wall, and as with everything on this job, well, it's not necessarily this job, it's just the way the garage is constructed, I think, and probably me being a bit overcautious, but because I've never used VFDs before, and because it's got a whacking great aluminium heatsink on the back of it, it's obviously going to be getting warm, and it does say in the instructions not to affix it to any flammable surface. Well, every surface in this garage, certainly on the walls, is flammable because it's all wood. So I don't really know how hot they get. I'm presuming, and again this is my lack of knowledge with electrics, but I'm presuming that with this machine, because I'm going to be running full bore, the VFD is not going to be doing as much work knocking everything back to run at a slower speed, so potentially that heatsink won't be getting quite as hot. I really don't know, that's just me trying to apply logic to electrics, and that's a very dangerous thing, because as far as I've ever worked out, electricity carries no logic whatsoever, or certainly no mechanical logic that you can apply to it. So what I've done is I've made out of a bit of scrap aluminium a couple of spacer bars. So we're going to screw those up to the wall, top and bottom, and then we'll screw the VFD onto the front of that, and that then stands the heatsink off the wall by 10mm. And I realise that the heat's going to sort of transfer into these, don't really know, we'll give it a go, see what it's like. I'm sure that'll be fine. So I'll get those fixed to the wall, and we'll get the VFD up fixed to these, and then I'll start poking wires into the bottom of it, and I'll bring you back when we're ready to blow all the fuses. Right then guys, VFD up on the wall on the 2 aluminium backing pieces that I made. Everything's wired up, and I've roughly tested it to make sure it's going okay, and I think it is. So we'll just power on. Just turn it, because I've not run these bearings in yet, so I'm not running this full bore, I'm only going steady with it. I've programmed in the slow ramp up, so if I press start now, we got there. So what I'm going to do now, I've got the back off. I've not, the front's not so critical because it's just a straightforward deep groove bearing, so there's no forces on that. The back, obviously with the preload, I just need to watch that as we run this for a bit, just to see it's not getting warm, or that it's not getting hot at least. So I'm going to play around for the next couple of hours, just leaving this thing running various different speeds, just gradually ramping it up, just to try and run everything in a little bit, because there's lots of new stuff now, new bearings, new grease, new motor, everything like that. So we're just going to run everything in for a couple of hours or so, and then once I'm happy with that, I'll then shift the machine back into its original position, level it all back up again, and yeah, we might be grinding something. Who knows? Well, there we go, guys. I've not done a spark pass on that. I just want to have a look at that without. So this is a rusty old parallel. Yeah, it's an incredibly good finish. There's a bit of marking in it, tiny bit, but you know, it's not as good as you'd get off a Jones and Shipman 540, but I never expected it would be. Probably that was towards the end. I was taking slightly wider passes and it was slightly deeper cut, so it's probably bounced a little bit, but that start point at the start of the cut here, very good. It's really very nice finish. So yeah, I'm chuffed to bits with that. I need to do a little bit more work with it, but happy days. So there we go. I'll just reposition the camera and we'll wrap this episode up. So there we go then, guys. That's been, through my own stupidity, that's been probably far harder work than it needed to be, but welcome to the Eagle hand operated surface grinder, to John's workshop. I'm very pleased with that. It's very quiet, very smooth, leaving a really good finish. A little bit of bouncing, but tiny little bit, and that's all. I've still got a bit more work to do in terms of the slideways, cleaning the slideways up properly, re-oiling them, cleaning the rack and pinion out. I've not done any of that yet, so I'll do that slower time, but you guys don't need to watch me doing that. So, and then next thing is to work very quickly on some kind of extraction unit, as I said before. So that'll be a new project, and we'll get the welding bench back out for that potentially, so that'll be something a bit interesting. So I know this one's been quite a long one, but I wanted to try and wrap it up in this last episode. So thank you all for watching, thanks for subscribing, thank you to the new subscribers that have come along, and I hope you've enjoyed that little mini series with the surface grinder. I've certainly enjoyed navigating my own faux pas, but you know, again, perseverance and keeping at it. It's a lesson to everybody. You can do anything if you keep trying and put your mind to it. So there we go. You know, I'm not an electrician, I keep saying it. I don't understand electrics at all, but you know, we've got a VFD now. First time I've ever used one of those. Dead simple, dead simple. So yeah, thank you to you all. As I say, hope you've enjoyed it, and we'll catch you all very soon on another video when we'll be making something else.